All right, so we worked through question number 5, where we're trying to determine if an argument is valid. We did that by writing each argument in its symbolic form and comparing it to those 6 common argument forms and finding that it fit one of them. And we could tell without doing a truth table that the first argument was valid and the reason was disjunctive syllogism. The second one was valid because it fit the structure of reasoning by transitivity, but that the third one was not valid because it turned out to be the structure of one of the fallacies, fallacy of the inverse. Okay. All right, what I thought I would do is just show you that if I had just get more practice with doing the truth table approach, what I could have done on this one, there's only 2 statements, so I could have used a truth table with just P's and Q's. So I'm going to get it started the regular way. Okay. Then form that compound statement by taking premise 1 and hooking it together with premise 2, and then seeing if that implies the conclusion. So notice we did that thing I was telling you that you always do. You hook the premises together with an and then you see if those premises lead you to that conclusion. Okay. All right, so on this one, I'm going to do P or Q. So I'm going to look at those first 2 columns and just think or. So I know it just needs one true to be true. So that's going to be true, 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 false. All right, let me go ahead and write the negation of P. False, false, true, true. When you do this, try to keep your letters kind of on the lined up appropriately. All right, now I'm switching gears and I'm going to be working on this and right here. And with and, I know they both need to be true. So that's going to be false, false, true, false. Okay. And really I'm done with this. Once I've gotten that column is the answer to what you see in brackets, what's in front of the arrow. So let me rewrite Q over here under Q so that it's right there where I need it. And let me focus on the 2 columns in green while I try to answer the last part, which is the broken promise. Now remember, on broken promise, if it starts false, it's going to be true. So those first 2 lines would be true. Then true followed by true would be true. And then again, I've got a false to start with. So see how at the end, it's all true? So you know it's valid. So if I were given the option, I could have done a truth table to determine that it's valid. If I'm told to compare it to an argument form, then I need to do this. I need to write the argument symbolically and then recognize which of the argument forms it is to decide whether it's valid or not. And I need to be able to name that argument form. So you need to work on that. All right, this one we know is going to be valid. This one is one that has 8 cases. So let me see if I can take that off. I want to get some more space here so it's not so jumbled up. Let me just move that one out of the way so that I can do my truth table for this one. Just move that to a new page. Okay, so if we wanted to check this one or do this one using a truth table, this one's a little more time consuming because you have 3 statements involved. You have a P, a Q, and an R. So I'm going to use the normal setup 4 trues followed by 4 falses to start with on the first one. And then 2 trues. Try to keep everything lined up since I don't have the lines up here. 2 trues followed by 2 falses all the way down. And then every other one for the third statement. Okay. Now the compound statement for this one would be P implies Q. Then it's Q implies R. Those are the premises. So I'm going to hook those with an and get an answer to all of that and see if that implies the conclusion, which is P implies R. Okay. So one fortunate thing is that to do P implies Q, I need to use the broken promise, and order matters, but the P and the Q columns are in the right order. So I don't really need to write the P and the Q all over again. I'm just going to look at the P and the Q column as I'm working and think broken promise. So I know that it's only false when I get a true followed by false. So remember, I'm looking at these 2 columns right here. And you see I have a true followed by false in both of these. But then if it starts false, we learned it's going to be true all the way down the line. So that's the answer to the first little set of parentheses. Okay. Now, I'm going to do the same thing for the second set, but I've got to be focused on these 2 columns right here. Might as well just do those in blue also. I'm going to do those 2 columns right there. Okay. And this is also the broken promise. And because the Q and the R are in the right order, I don't feel that it's so necessary for me to rewrite those right here. I can just look at those 2 columns as long as that's what I'm focused on. And I'm thinking it has to be, if it's true followed by true, it's true. But true followed by false, that's going to be false. Then if it starts false, so false followed by true, that would be true. And a false followed by false would also be true. I haven't broken my promise. Then true followed by true is true. True followed by false would be false. Try to keep your things lined up with where you are relative to the first column that we did. Keep those lined up. Right, false followed by true, false followed by false. Okay, so that's the answer to the second set of parentheses. All right, now I'm going to go in and do this and column now. So I'm switching gears from broken promise to and. Ands are true if they're both true, so that's true, then false. They have to both be true. Oops, not true. I had a momentary lapse. I'm supposed to be thinking and, so they have to both be true. So that would be false, that would be false, but here they're both true. That's false. Here they're true, here's true. Okay? So I have T, 3 F's, a T, F, T, T. Okay. All right, I always like to double check before I move on. So that's the answer to the bracketed component. I'm really done with this and done with this. Okay. All right, now I need this part, this P implies R. And this is going to be a little bit harder. You know, I might suggest we write, maybe I will, since they're so far away. I might, underneath P, go ahead and write the 4 trues, followed by the 4 falses. And then R was TF, TF all the way down. Okay, now I'm going to work on that broken promise in the middle. Here, that one. And I know that the only time it's false is when I have a true followed by a false. Okay. So now that column that I just put a box around is the answer to this part in parentheses, the conclusion part. And so now I'm going to focus on the 2 green columns while I go and do the final one, which is that arrow, that broken promise. So T followed by T would be true. If it starts false, it's true. So I got several falses here. Now I have a true followed by true, so that's true. False followed by true, that's true. And then 2 more trues followed by trues. And we knew this had to turn out to be all true because it actually was a standard argument form called reasoning by transitivity. All I'm trying to demonstrate is the truth table would have told us it's a valid argument. But if you recognize the argument form and it says it's okay for you to use it, you really already knew it was valid because you recognized it as reasoning by transitivity. Okay? All right, so one more. We already determined it was invalid because it fit an argument form that we knew was invalid. Well, you might have been given the choice and you might have preferred to use a truth table. So here's the structure, and it only has P's and Q's, so this one's going to be a lot quicker. And we'll do the standard setup, 2 T's followed by 2 F's. Okay. And then I need to make that compound statement that takes your premises and hooks them together with an and then we're going to see if that leads to this conclusion over here. Okay. All right, so now P implies Q. That would be true, false, true, true, because I'm looking back at the P and the Q column while I do it. Let me go ahead and jot down not P, which would be F, F, T, T. All right, I'm going to now work on the and, so they both have to be true. So this would be false, false, true, true. And I'm actually done with those 2 columns, so let me cross those out. Next, I'll do the not Q. That would be false, true, false, true. And then let's take those 2 columns, and we're supposed to be thinking about the broken promise again. So if it starts true, it's true. But true followed by false would be false. True followed by true is true. So you see how it didn't turn out to be all true? Not all true? So it's not a valid argument. So the argument is not valid. Okay. We knew it should have turned out having at least 1 F somewhere because it did fit the structure of the fallacy of the inverse. So I was just trying to demonstrate that truth tables could be used, or if you're allowed, you could compare it to one of the regular argument forms.